Imagine two particles sharing a single identity. Back in 1935, Einstein calculated that two particles could be interconnected such that they would behave as one. But this meant that electrons would be exchanging information at a speed faster than light. So Einstein thought he was mistaken and declared this phenomenon to be impossible. And at the time, no experiment could be performed to prove whether this was true or not.
Welcome at the lab of Ronald Hansson, part of the QTech. This is where they're working on the world's first quantum computer in about 10 years. Could you explain to me what is entanglement?
Entanglement is a phenomenon that is predicted by quantum theory. And it says that two particles can have a link, they can sort of share an identity, and that makes them behave as if they are one.
But how do you prove entanglement? Electrons could be sending signals to each other to coordinate their behavior, or maybe exchanging places very fast.
And so what we have done here in Delft is to, for the first time, do an experiment where all these loopholes are closed. So we know for sure that the particles could not have communicated, not even by the speed of light, because our measurement is so fast and the particles are so far apart that this is just impossible.
Diamonds are used to emit and catch quantum particles. In this experiment, one of these diamonds is called Alice and the other Bob. Both have their own lab.
So we are in Bob's lab now, and the diamonds actually emit light, and we catch the light from those diamonds and we lead them through the fibers all the way to where we've just come from.
Once the particles are far apart, their state is closely measured using high precision tools. If their state is identical, the experiment has been successful in proving the particles are entangled.
Are there any plans for other further experiments?
Well, what we want to do in the next 5 years or so is to extend the distance. And we would really like to make a small quantum network, a small quantum internet as we call it, between several cities in the Netherlands, so between Delft and Amsterdam, maybe The Hague. And then also do the tests that we've now done across 1 kilometer, across these bigger distances.
If we had entangled particles all over the world, we could use these to create a quantum internet. An unhackable version of the internet we have today.